This is Math 2, 6.3 notes. That's Unit 6, Lesson 3. The title is Properties of Triangles. And the first one we're going to go over is the side splitter theorem. Side splitter theorem. Looks like this. Let's draw our triangle. I'm going to call this triangle Q, X, Y, and I'm going to show that these two lines are parallel. This is not a side splitter. Notice these sides are not congruent. There's no markings there. We'll label this R and this S. So as long as RS is parallel to XY, it doesn't matter where it's placed. It could be across here, across there. As long as they are parallel, this property will always hold. The length of QR over the length of Rx will always equal the length of QS over the length of SY. Alright, so I will show you an example of what that looks like. Solve for X. Okay, I'm going to give you that these two lines are parallel. This little segment here is X. This segment here is X plus 4. This segment here is 12, and this one down here is 18. So when you make your equations, it would look something like this. The length of the top piece, which is X, over the segment, the length of the bottom segment, which is X plus 4, equals top over bottom, over 18. Now, that's it. X over X plus 4 equals 12 over 18. And then you go through and solve. You cross multiply. 18 times X is 18X. 12 times X plus 4. Don't forget you do have to distribute there. So you get 18X equals 12X plus 48. And now you are ready to solve. Subtract the 12X. 18, take away 12, is 6. 6X equals 48. Then you go and divide both sides by 6. And X equals 8. Sometimes they'll ask you for side lengths. You'll have to plug it back in, but this one just asked for X, so we are done. Really quick side note, some kids will do it this way, and let's check if it works. X over 12 equals X plus 4 over 18. Cross multiply, we get 18X equals 12 parentheses X plus 4. I don't have to go any further to see that it is going to work. There's the 18X, there's the 12 parentheses X plus 4. So they are the same thing. So as long as you do top over bottom, so left side, right side, or top, bottom, you're fine. As long as you don't like jump across, you're good. Just keep it consistent regardless of which way you go. All right, corollary to the, it's number 1, corollary. It also works for multiple parallel lines. So if I have multiple parallel lines, cut by two transversals, the transversals do not have to be parallel. So there's my transversals. I'm going to call this here point A, that point of intersection B, this point of intersection C, W, X, Y. All right, so I'm going to give to you given information. AB is 6, WX is 18, and XY is 12. I want you to find A, the length of BC, and B, the length of AC. Okay, so where is the length of BC? BC is this length right here. And I know this segment is 6, this is unknown, this is 8, this is 12. I treat it just like I do up on that top one, and I make my proportions. So 6 over the unknown side, we'll just call it BC, equals 18 over 12. 6 over the unknown equals 18 over 12, or 6 over 18 equals the unknown over 12. And you cross multiply. 6 times 12 is 72, equals 18 times BC is 18 BC, and then we go and divide both sides by 18, and 72 divided by 18 is 4. BC equals 4. All right, so we just found that segment right there is 4. Now, they're not just asking for that, they're also asking for AC. Well, if this is 6 and that is 4, how do we find AC? We do 6 plus 4, which is 10. And they will ask you questions like that on the test. They might not even ask for BC, they'll go straight to ask for AC. So you have to solve it first, find the 4, add it to the 6, and 10 is your final answer. All right, next piece is called the triangle angle bisector theorem. All right, so let's draw our triangle. And this is the side splitter was dealing with side lengths. Right now we're going to deal with angles. So I'm going to call this A, B, C. And I'm going to bisect angle A. It doesn't matter which angle you bisect. Right now I'm bisecting angle A. And where this angle bisector meets its opposite side, I'm going to call that D. And the rule is AC, that's this length, over CD will equal AB over BD. Okay, AC over CD, AB over BD. All right, so let's try an example. Solve for X. All right, I'm going to bisect this angle here, and you know it's bisected because it'll either tell you or it'll give you markings. X, 12, 20, 16. All right, so whether you do 12 over X or X over 12, it does not matter. Or you could do X over 20 and then 12 over 16. It is totally up to you. I'm just going to do X or 12 over X equals 16 over 20. 12 times 20 is 240 equals 16 times, or 16 over, sorry, 16 times X is 16X. All right, 12 times 20 is 240, 16 times X is 16X. Divide both sides by 16. 240 divided by 16 is 15. And once again, if you had done it instead of 12 over X, X over 12 equals 20 over 16, it would have worked out the same way. You'd have X times 16, 12 times 20. So there's a number of ways. Some people will even do, let's check this way, X over 20 equals 12 over 16. Still works the same. There's the 16X. There's the 12 times 20. So there's a number of ways you can do it as long as you don't jump diagonally across. All right. We will discuss more of this in class. That is it for this lesson.